And here are the solutions to the remaining problems of the Unit 3 review, 21 through 30. So for question 21, we're using the properties of logarithms just to fill in the blank here. So on the left side, when we're subtracting, we would get log base 9, and we would divide the values here. So we're looking at 5/4. So the blank here, the answer would be 5/4. For B, in order to get the 55 here, notice we're adding, so we need to multiply whatever number goes here by 11, so this would be a 5. So we would have log base 8 of 5 plus log base 8 of 11 would become log base 8 of 5 times 11, which is 55. So 5 would be our answer. Okay, and this last one here, we're using just the power property. So this 2 is just going to become the exponent of the 5. So we'll just rewrite this as log base 3 of 5 squared. So that's really just 25. That's going to go in here because we'll just square the 5. Okay, question 22 is another compounding interest problem. If we notice here, it's compounded continuously, so immediately we should be thinking of the PERT formula, A equals P times e to the RT. So we're looking here at how much should be invested. So in this case, we're looking for the initial amount. We want to have $1,500 in 3 years, so the $1,500 is going to go in for A, P is going to stay a variable, and then it's e to the 0.07, and T would be 3. So really, we're just going to say P is going to equal 1,500 divided by e to the 0.07 times 3, because we don't want to do any intermediate computations. So this would be the exact value, and then as we go to type this in, P should equal $1,215.88. Right, in this last set, we have a lot of properties with logarithms and equations involving logarithms. So this we just want to condense and write as a single logarithm. So we should be able just to do all of this by looking at it. So right now, this 1/4 becomes the exponent of z. So we're going to have z to the 1/4, and I know it's going to go in the numerator because it's a positive leading coefficient here. And then we'll have times, and then 4 will become w's exponent, and we're going to multiply it by z to the 1/4 because there's a plus sign here. So we'll have w to the 4th also in the top. And then since this last part is after minus sign, this part is going to go in the denominator, and we just have a y. And that's our answer. Let's keep all this in parentheses, though. All right, for question 24, talking about one-to-one functions again. So here for the inverse of g of 9, so if 0, 9 is on g, then is a point on the function for g, then 9, 0 would be on the inverse. So g, the inverse of g of 9 would just give us 0. Let's go ahead and find the inverse of h of x. So if h of x is equal to 3x plus 10, we want to rewrite h of x as y equals 3x plus 10. And then switch x and y, so x equals 3y plus 10. And then we'll solve for y, so we'll get x minus 10 is going to equal 3y, and y would equal x minus 10 over 3. So that means the inverse of h of x is equal to x minus 10 over 3. Now you've seen enough of these problems that we should know if we took h and did the composition of h into the inverse, we should just be left with this -3. But let's just check. So let's do h, because this is just saying the inverse of h of -3. So we first want to calculate h of -3. So we're looking up here. So that becomes 3 times -3 plus 10. Gives us -9 plus 10, which is 1. Then we take the inverse of h of 1. So that becomes 1 minus 10, I'm substituting it in here, over 3. So that becomes -9 over 3, which is just -3. So it's typically whatever's here should be our answer, but we need it just to verify that. All right, here we're just asked to evaluate each expression. So I want to rewrite this. We could say log base 8 of 1 over 64 is equal to y. So then this becomes 8 to the power of y is 1 over 64. Now this is a reciprocal of 8 squared, so that means y is equal to negative 2 because 8 to the negative second becomes 1 over 8 squared, which is 1 over 64. So this is negative 2 for this answer right here. The next one will have log base 3 of 27 is equal to y. So 3 to the power of y is 27. That's 3 cubed. So we say y is equal to 3. So 3 should go in there. All right, question 26 deals with inverse functions. So if you recall, if f of g of x is equal to g of f of x, which equals x, then f and g are inverses of each other. So for a, we want to first just find f of g of x, which becomes f of x minus 2, because g of x is x minus 2. So I'm going to substitute in the x minus 2 here for x. So we get x minus 2 plus 2, which is equal to x. For b, we want to find, or rather, sorry, this is still part A, but the second part. We now want to find g of f of x, which becomes g of x plus 2. So now I want to substitute in the x plus 2 and here for x. So we get x plus 2 minus 2, which equals x. So here we could say f and g are inverses of each other because f of g of x equals g of f of x, which is equal to x. Okay, for part B, we'll do f of g of x. So this becomes f of negative 1 over 3x. So I want to substitute this entire expression right in here. So now this becomes 1 over 3 times negative 1 over 3x. So what's going to happen here is that the 3's are going to divide out because technically this is a 3 over 1. So we're left with 1 over negative 1 over x. And I can multiply top and bottom here just by a negative x. So now I really get just negative x because these will just cross out here. So that's not equal to a positive x, it's equal to a negative x. So f and g are not inverses of each other because f of g of x is equal to negative x. There's no reason to even check the other one. So filling in the blanks here, f of g of x would equal x, g of f of x is equal to x. Here we get a negative x. And even though it's asking us to check the other one, it's not necessary because they're not because of this right here. But let's go ahead and just practice. Let's do g of f of x. So this becomes g of 1 over 3x. So now we're going to get negative 1 over 3 times 1 over 3x. Again, the 3's divide out, so we're left with negative 1 over x. Same situation here, multiplied by x. Let's go across here. So we'll get a negative x. These divide out, so that's also equal to negative x. So again, that justifies that they are not inverses of each other. Okay, here's a logarithmic equation. If you take a look at the bases first, we want to get common bases here, and we can in this case because 3 can be raised to a power to give us both numbers. So we want to get a common base of 3. So when we're able to do this, make sure we do this because now we'll be able to get a specific answer rather than leaving it in terms of natural logs or logs. So I want to rewrite 27 as 3 cubed and 9 is 3 squared, and then it'll get multiplied by the negative x plus 2. So now that I have common bases, I could just set the exponents equal to each other. So we'll get 3 is equal to 2 times the quantity negative x plus 2, distribute the 2, so we'll get a negative 2x plus 4. Subtract 4 from both sides, so we'll get negative 1 is equal to negative 2x. Divide by negative 2, a negative divided by a negative is a positive, so we get x is equal to 1/2. right, for 28, in this case, the way this is presented to us, we could just rewrite exponentially. So we would have 5 squared is equal to negative 2x plus 5. So we get 25 is equal to negative 2x plus 5. Subtract 5 from both sides, so we'll get 20 is equal to negative 2x. Divide by negative 2, x would equal negative 10. And just to check, negative 2x times negative 10 is a positive 20. 20 plus 5 is 25, so that's a positive number now, and 5 squared will give us that 25. All right, in this case, we want to first start by isolating the natural log part right here. So I want to first divide both sides by 2. So with the natural log of x plus 1 is going to equal 2. We can rewrite this as log base e of x plus 1 is equal to 2. And now we can rewrite this exponentially. So e squared is going to equal x plus 1. And then x would just equal e squared minus 1. So again, this would be the exact answer. Approximately, we're going to round to the nearest hundredth, we get a 6.39. If you were to type that into your calculator, that would be the approximate answer. And then our last one. For a, we want to rewrite as a logarithmic equation. So what this means is we're going to just take the natural log of both sides. So if we start with e to the x is equal to 5, the natural log of e to the x is equal to the natural log of 5. So here we're just left with x is equal to the natural log of 5. So that would be it. For b, rewrite as an exponential equation. In this case, we want to rewrite it as log base e of 2 is equal to y. Therefore, e to the y is equal to 2. And that's all that was asking.